Hello, everyone. Hi, good morning, good evening, wherever you are joining us from. Today we are on the third session on the Generative AI for Software Developer series. My name is Moria, and I'm here today with Yarden Dor and Adi Stein, who worked together with me on this series. We hope you enjoy this content if it's the first time you are joining us or you've been in the previous sessions as well. So this series is actually part of the Reactor program. For those of you who are new to the Reactor, Reactors are community hubs for developers and startups where they can connect, learn, and meet. We have physical locations globally, worldwide, but we also operate online and we offer programming every day on different times. Check out our website. You can subscribe to our events and stay updated with the upcoming events that we offer. We also offer events in different languages. So if it's relevant for you, you can also filter the event to different language and see the language that you prefer. The Reactors is empowered by the Microsoft Learn program. Microsoft Learn program, it's a free platform for developers and organizations that offer you to access free training, certifications, documentation, online events, on-demand events, really everything you can think of on different technologies. You can choose your preferred technology and you can find all kinds of free resources that you can view and you can learn from your home, from your computer, on your own time. And that's the good thing about the Microsoft Learn, that it's always available and you can access it whenever it works for you. If you scan this QR code, you will reach the Microsoft Learn platform. But if you want to be a bit more specific, you can scan the next QR code and then you will reach the AI Learning Hub of Microsoft Learn. The Learning Hub, the AI Learning Hub actually gathers all the AI different modules and learning paths that are relevant for you. Of course, it's relevant also for this series, and this is why we are sharing it today. How it works is that you answer a few simple questions on your preferred training, and you get recommendation that works for you. If you scan this QR code, and we're also sharing the links in the chat, so you can don't worry if you're missing the QR code. You can also access the links by clicking them on the chat. So today's series is Generative AI for Software Developer. As I mentioned, today is the third session, Coffee Chat with Documents as a service from zero to hero, and I'm going to present today's speaker soon. If you haven't joined us, you can view the last two sessions that we had on Semantic Kernel and Copilot, stopping the Copilot FOMO. On our YouTube channel, there is a whole dedicated playlist just for this series. If you scan this QR code, you can register for the next session next week on the same at the same time, or you can also view the events available on YouTube on demand. Another series I wanted to share with you is Spotlight on Applications, Innovation, and AI. It is another series that we are running in the Reactor, already started about 2 weeks ago. It's a total of 7 sessions. You can scan this QR code and reach specifically this series. If you want to register for the upcoming events, you can do so by scanning this QR code. As a reminder, also all of our sessions on this series are recorded and available on demand on our YouTube channel. If you scan this QR code, you will reach the Microsoft Reactor website where you can subscribe to our newsletter and stay updated with the upcoming events. We are also on Twitter, X, how it is now, meetup.com, Facebook, and really different platforms. So feel free to choose your preferred one and you can stay updated with our events. Before we start, I wanted to take a minute to cover the code of conduct of Microsoft. So Microsoft is dedicated to empower every person and organization on the planet to achieve more. And this includes, of course, Microsoft Reactor. So at our events, we seek to provide a respectful, friendly, and professional experience. So please mind that when you are chatting, when you're writing in the chat. Okay, so that's it from my end. I'm gonna pass it over now to Maya Shavim. So Maya Shavim is a senior software engineer in Microsoft, and she's gonna present today's session. I'll let Maya talk a bit more about herself and the session. So hope you enjoy it. Maya, over to you.
Okay, hi everyone. Just give me a second. I need to somehow share my screen, so give me a second, okay? Um, Meanwhile, you can actually answer the question about where are you joining from, and I would love to hear. Okay. So I just have a problem with the presenting. Try to show this. Hmm. No, not this one.
Meanwhile, Maya, while you are setting up your computer, feel free really to share where you're joining us from. As I mentioned, the Reactor program is global, and we have people joining from different countries. It's always great to see people are joining from different locations. So do share in the chat. Also, if you have questions for Maya for this session, feel free to post your questions, and Maya will take the time to answer the questions at the end. So Maya, back to you.
Okay, thank you. Thank you, Maria. Oh, yeah, technical problem happens all the time. And this time with my browser. So welcome to our sections today from everywhere in the world, Spain, Ukraine, and everywhere else. So today we're going to have to build a coffee chat with documents. What does that mean? Well, let's find out. But first and foremost, my name is Maya Shavin. I'm a senior software engineer at Microsoft in the group Industrial AI group. Um, our group is the group that we are leveraging different LM services to build solutions and applications that have AI integrated for industrial specific, including document Q&A. And I'm also a published author. Well, if you are interested in learning a new front-end framework that is fast and not furious, check out my book, Learning View. And I'm also a Google Developer Expert, organizer for Vue Cherish Israel, and Cloudin Ambassador. And you can follow me on Twitter or LinkedIn at Maya Shavin, or check out my website at mayashavin.com, where I usually talk about documented all my journey in the high tech and what I've been learning both in AI and in the web together. Okay, that's enough about myself. So what is the sections what is the objective of our section for today? So in these sections, we are going to go through the general flow architectures for our document assistant, or you can call it document Q&A, or you can call it chatbot, or you can call it doc Q&A, whatever name it is. Is in the end of the day, is still document assistant Q&A. So we call it document assistant just for the sound of it more professional. Okay, so and then after we got through the flow architecture, we go into implement the different component we're using LM services, and we're going to evaluate how to see how we can evaluate the quality of our document assistant and what the constraints for the evaluations process. And lastly, bonus, we can see how we can create a document assistant using Azure AI Studio directly. Okay, let's start. But first and foremost, let's recap. We heard a lot about generative AI. You heard about a lot about Gen AI. Anything? What exactly generative AI? Generative AI is an AI that can generate text and media from a variety of user inputs. We call it prompts. So the nice thing about generative AI and why it's so popular is because under the hood, it's using LM, large learning model, which is a very flexible machine learning model that can process and can predict kind of next words or text according to the user input, which means it's also learned from existing data, but it also can learn from what user given to it. Some of the LLM that was popular for generative AI is, you know it, ChatGPT, Copilot, Midjourney, DALL-E, and so on. Okay, so when we talk about LLM as a service for generative AI, what is LLM? LLM stands for Large Language Models, with the kind of the structures a little bit hard for me to pronounce. LLM. It's made my tongue a bit twisted. But anyway, the large language module is the machine learning module that can process human language inputs differently with traditional machine learning module that will be trained to do a specific task and only a very specific things and cannot be extendable. LLM is very, very flexible that it can do its own training both in a supervised and unsupervised manner, which means it can also train from the data sets you give it. It also can train from a few short, like fine tuning, and it can also train from the input the user given us in order to kind of predict what the next thing the user may be interested to hear or to receive. Thinking it like a friend that can give you answer whenever you ask it a question, and that somehow give you the desired answer in a manner of some options that it more or less fit you. And the reason why LLMs is become very popular or generative become popular is all because LLM now available as a service that is offer you APIs that for developers can build AI application on top of this, much more straightforward than using the traditional machine learning. You don't need to have a PhD. You don't need to do a master degree on machine learning. You still can understand how to use LLM API if you invest a minimum of time. And lastly, LLM works with tokens. Every LLM service comes with a token limits to make sure that you don't abuse it or it will perform within these limitations. And so one of the most popular LLMs as a service we have up until today. So we have OpenAI with GPT, Google, we have Gemini, Microsoft have Azure OpenAI, Meta have Llama, and other open source LLMs such as Hugging Face or Cloudy for Anthropic, and so on. And before we move on to more specific LLM here, let's take a big step back and ask ourselves, what is the token? We heard a lot about tokens, right? So when we talk about it, we say, okay, we need to make sure that we don't go over the token. We have enough token limit for this. We have enough token limit for that. What are tokens? Tokens, we can understand that it's pieces of words. It can include in trailing spaces and subword because it's word. Word can be white space, word can be number, it can be a new line characters, and so on. And that's the reason why when you talk about giving input, usually you have to do some kind like a format the input, like cleaning them out of trailing space or new line on the things that can affect the token limit and can affect the AI to respond. So how do we know how to count the token? So according to OpenAI, one token is approximately about equal to 4 characters in English. And one are talking about 75 words, and not a lot, right? So that's also the reason why when we talk about document assistant, we will have things, we do extra thing in order for us to be able to stay within the token limit. So now how we are going to actually count the token based on the approximate calculations? Well, there's many ways for it. One of the options is to use the token counter. So for the token counter, you can go to the website tokenizer.streamlit.app, and you can try to write your text or paste your text here, and it will give you the calculate of how many token it would take. Again, it can be perfect, like it can be approximate. I mean, there's something wrong in the middle because this is an open source project also. So it's kind of reference for you to know how much token are you using. But other than that, don't take it that the de facto when you calculate the tokens. Okay, so that's about the token. Now let's go on and talk about a bit more about Azure AI services at our AI services here. So Azure offer a lot of different services in order to help developers to build applications or AI applications on top of them. Some of those are very popular that you already know, such as Azure OpenAI, which we will talk a bit in the next slide. And other things like Azure AI service that provides smart search using LLM, document intelligence for parsing document, and other like translator, language, and speech. So the reason why I'm talking about these specific service is very related to document assistant, what we will review in the next following slides. Let's talk about Azure OpenAI. What exactly is Azure OpenAI? So Azure OpenAI is actually OpenAI with extra capabilities for enterprise. For example, compliance, security, and other so on and so forth, capability that extended OpenAI a bit more for the industry requirement. So, which means Azure OpenAI included all the GPT model that OpenAI has. And it also have embeddings module. Embeddings module is very important for building embeddings for search, for smart search. DALL-E, Whisper, and text-to-speech. The last three are only preview at the moment, but it's also good for later if you want to do extra capability like image generations or convert from speech to text and feed it to the document system. Okay, so that's enough recap about all the AI service that we have. Now let's move on to document assistant, or we can call it chatbot, or we can call it doc Q&A. It doesn't really matter. One thing I need to share here that I found like I think yesterday or a month ago that Air Canada got sued by some kind like a misleading answer from a chatbot. So the argument here is still whether this chatbot are built on top of AI, like they claim it built on top of AI, but this is something when you go to build a document assistant or document Q&A or chatbot, things like this can happen if you're not careful, if you don't understand what you're doing here. Okay, so what exactly is document assistant? Sorry, I just have a lot of, I just have a cold yesterday. So when we talk about document assistant, it's a very simple UI, it's a very simple app of features. You have an input, you have a button, user will ask a questions, send it to the AI will answer it. And the answer has to be against a document range. So when we talk about the document range, there's two options here. The first scenario for document range is on-the-fly document, which means the user not only provide the answer, it also provides a document, like upload a document, so that the AI can query the answer on top of this document that is received. The second option is the pre-upload documents, which means the user don't need to upload anything, and the AI, the services, the document assistant already trained on top of the documents provided previously, and they pre-deploy the service. So, and this is more relevant to industry such as manual, such as company policy. And we, in this talk, in these sections, we're going to discuss about how we're going to implement a document assistant again, the second scenario, which is a pre-upload document set. Okay, that's simple, right? This, the requirement of the scenario is pretty straightforward. You ask AI within the document range that you pre-uploaded, right? So when we talk about this scenario, they actually split into two flows. The first flow is the injections, where you already have a set of document and you need somehow to ingest it to the AI or to the search database so the AI can query from, which is the second flow, query. And when we talk about the scenario, it actually have to move sideways, which is the injection comes first. Only when the injection is done, user can query answers from the AI. Okay, so let's take a look about our flow for document assistant here. So the injection flow, let's take a look about the injection flow. So injection flow, the first thing is, first and foremost in requirements, we have a set of documents. The document is actually text. It can be a PDF file, it can be a HTML file, it can be an MD file, it can be just raw text. It doesn't really matter. What it does is that in the flow, when we receive the document, we have to find a way to load and parse these documents and split them into chunks, structured chunks. And why so? Because AI cannot read the whole document of 300 pages. It would just not working because we have a token limit. So we have to split the document into smaller chunks and structure in a structural way. So what chunks is also, again, chunks is like text, such as if you have a document have a header, a body, and a footer. So the chunks can be the chunks of header, the chunks of body, and the chunks of footer, and so on. And once we have the chunks, we create the embedding that for those chunks. Sorry, 1 second. Okay, sorry. And once we have the embedding, we can index the embeddings, index the chunks that with the embeddings into a search database, the smart search database that we can query these chunks afterwards. This is the full component of the injection flow, right? Now, let's take a look at something more interesting in this flow. The thing interesting in this flow you may or may not aware of is the creating chunks embedding. So what is this creating chunks embedding is for? Well, it's using for vector search and semantic search algorithms in order to query the right chunks according to the input it received. And what is embedded? Well, in this example, you can see the flow of how we can create embedding. So the document here is actually text. It's just the document is written document just for the terminologies, but we put text through an embedding API, which is an LLM, embedding LLM service. And what we will receive will be the numeric representations as the vector representations that can be used, can be sent to the machine learning module or search algorithm to consume and to use it for performing search and compare between the right chunks and the query. Okay, and that comes to the flow of the vector search. The vector search is something new because it gives a very accurate response for searching. So in this flow, what our create embedding component fall into is the first part, where we have image, document, and audio. In our scenario, we have documents. And from the document, it goes to the embedding LM embedding service, will be transformed into a vector representations. Each vector representation stands for chunks. And then when we have the chunks, we can put it into the search database and it's ready for the search, the smart search to perform vector search on top of it in the second flow called querying. Okay, so for querying, what we do, first we receive a query from the user. We'll have to create embedding from the input user. We cannot use as is because in order for us to search on something with embeddings, you need to compare between embedding and embedding. You cannot compare between text and embedding. It doesn't work like that. And then when we got the map chunk, we'll ask for summarizations from another LM service like GPT. And we have to pass to it a single string that combine between the query, the original query, and the number of the chunks, which is on the text that we found relevant. And then when we receive the answer from the GPT, we will format the answers, whatever we need to format in order to return to this client side at this answer. This is the flow of query. Pretty straightforward, right? Okay, so how did this fit into the vector search flow? So for creating embeddings for query fit into this flow on the right side, where you can see that we get the query, we transform into embedding, we get the representation, and then now the search, the search algorithm, or we can call smart search service like AI search, can go and compare it, find the matching chunks using different search algorithms, such as the k nearest neighbor or other algorithm. So this is just a very example of the vector search flow. In reality, you can choose to change to use different algorithm, not just nearest neighbor, but this is not the scope of our talk today. So in this case, we already know what we do and how we flow, how the vector search doing, and how we do the injection and how we do the query. Now come to the next question. So we understand all the components of the flows. So what kind of service or which services, what LM services we can use for what component? Well, let's take a look about our injections. So in our injection flow, we have 4 components. For the load, parse the document and split the document in structured chunks. If it is PDF, HTML, and you need to have a help of external service. Either you write it yourself, like make it your own model to parse these documents and split them into chunks, or you can use the document intelligence service from Azure AI Services. It would just go and take the PDF file, for example, and then parse it into parse and then split them into structured chunks according to table, according to pages, according to sections, so on and so forth. Depends on how you configure it. And the next component is create chunks embedding. We know that we need some kind of embedding LM service. For that, we use Azure OpenAI text embedding service to create the embedding chunks. And finally, we're going to index the chunks with the embedding into a search database, which is Azure AI Search. In this case, you can also use probably Elasticsearch or Pinecone for this. Doesn't really matter, but we need ways that can store it. It can perform the search for the smart search for us. So that is the injection flow. For the querying flow, for the query embedding and from input query component and as for summarizations, both of these we need to use Azure OpenAI's API. For the query embedding, again, we're using text embedding. For summarization, we're using GPT. Okay, and for searching, we can use Azure AI Search to perform the search for match chunks. And finally, we can do and finally, we can perform our own logic for formatting chunks info. And that is the own three component that we need to use external services. It sounds a lot of work here because for each component, we have a different services. We need to implement it. We need to read the API. We need to write the code that's using this and talk to them and kind of orchestrate the input on one side and change it into the output to another service, right? Too much work. So if there are more straightforward options to do that, well, let's come to Azure OpenAI on your data. And yep, so what is Azure OpenAI on your data? Well, Azure OpenAI on your data is Azure OpenAI with extra capability called on your data, which means it's providing out-of-the-box solutions that leverage different services like AI search, storage, OpenAI service, and other service that not even in Azure, such as Python, Elasticsearch, Cosmos DB, and also Hugging Face maybe, to help you to perform injections. So provide you an injection API, and it also provide you a querying API that allow you to plug in different data source If you already have a data source that with already indexed, like in Python or not just Azure AI search, you can plug it in the Azure OpenAI in your data querying API and use it to query, to send the query and get back the answer on again this data source. And it's an out-of-the-box solution, so it comes with a pre-config things with default system prompt, and it's tailored specific to Q&A scenario, which support for localizations for different languages. Okay, so and I have an SDK for that. So let's take a look at our injection flow, our flows for document assistant with all the different services we have to use. So now instead of using these 3 different services and I have to implement our own orchestration, we can just use the injection API from Azure OpenAI on your data to perform all of this. And for querying, again, we can replace these 2 services, Azure OpenAI and Azure AI search implementation, with just using the querying API from Azure OpenAI on your data and save us the headache of manually create embedding and sending, combining the summation and so on. Okay, so how are we going to implement it? Let's come to our demo. So for our demo, first and foremost, what I already set up here. I'm not going to set up everything from scratch. So for the demo, first of all, I kind of assume that we already have the instance created for OpenAI, prop storage, Azure AI search. Well, it's more, I like to use Azure demo, and you can choose anything you want that can match for this. But for Azure prop storage at the moment, for Azure OpenAI, you have to have prop storage where you store the data, and so that you can use it for injection API. It doesn't provide an API that you can upload the base64 files to Azure OpenAI in your data, and it will just index it for you. You have to upload somewhere first, and then there's no history saved because I don't want to deal with user privacy. So I just want to receive a question and I'm going to give an answer. I'm not going to keep the chat history. And lastly, I'm writing these services using TypeScript with Azure HTTP functions. Okay, so let's go and do an injections API with injection API, shall we? So in this API, we go into see what is needed. So we need to pass the API key, the service endpoint for the search, and the connection string of the container for the storage, and also the embedding information for the vector embedding. And for the body param, we have a data refresh interval in minute, and also that is for how much time to refresh the data. And you can also go into the documentation and see how we can do the injection here. Okay, and what we're doing here is that we're going to copy the URL, we compute the path for injections. So in this case, we compute the path from according to the syntax from the documentations. So we provide the endpoint. The endpoint we already get from the credentials, which is just take it from the environment variable. And then we provide jobs ID, which is the random job ID using crypto.random UUID. Okay. And the second thing we're going to create a header, which the header is all the information like API key, endpoint for the search, and so on, and endpoint for the embedding. So here we have to verify that we get the endpoint for the embedding correctly generated by Copilot. Okay, and pretty much that's it. We have the container, we're going to extraction. All of this I already get it from credential from this environment variable. And the next thing we're going to compute the payload. Well, we have to compute the payload for the request, which we don't need everything. We just need to have the data refresh interval in minutes, which I kind of put in 60 minutes to refresh the data, but you can put it more if you don't need to refresh it so frequently. And then we will do the ingest data using the API from Azure OpenAI on your data. Okay, so it's the put method. and we put the header with extend from the have would get from our header before, and we put the body. Okay, and that's it. And we can also console log the response to see what the response we receive, and we have some catch and error and so on. So next, how we going to test it? Okay, so when we run the Azure functions, when we run it locally, we can run it by click on the debugging, and it will give you all the API, the endpoint for our functions, and you can also see it in the Azure tab here. And let's go to, let's send an injections post request to our Azure function here. When you send it, you will see because we put a breakpoint in the injections, so we can see what is the response from the server, from the Azure OpenAI data, and here it will tell us what the chunk size that we have, and it also tell us the ID that for this job, and also give us some status and what is the state progress for that. As you can see, it's not running yet. So what we can do in order to understand whether it's finished or not, we can add another get API to get the status when add in some polling, so we know when the job is done. In addition, you can go here to the Azure portal, go to the search service, and look at these indexes. And you can also see how the indexes was formatted. For example, in here I have the document Q&A index already done with the vector profile, but it's already created by O1, so you don't see it here. And then you can also do the search to see the actual chunk was stored here. So here you can see the content vectors is for each chunk have a content vector which will be used for the vector search. Okay. Okay, and that's it for an injection API. Now let's go to our flow, querying flow. How are we going to do that querying flow, which is more interesting. So querying flow first, we need to define some types here according to the API documentations. So we have a data sort param with the index in scope, meaning it has to be only the scope and not going to have hallucination or misleading or anything outside the scope. We provide semantic configuration for semantic search together with vector search because we most likely will use hybrid search between semantic and vector search for better accuracy. And of course, search diagram, we also have the endpoint, the key, the query type, and the fields mapping, not necessarily for field mapping, but it's mainly for like adding whether you want to map a field to something else that's more relevant to your data set, to your data structure. Okay, great. Now let's go to the documentation. You can also see the documentation here, what it has here. You can copy the path format, and then we can compute our path format as part of our functions ask. Okay. Okay, so let's go here. We also, again, we get the credentials from the environment, and we also get the payload from the function, Azure function, which is query. It's the input query. We also do some kind of like a sanity check before, and now we're going to implement get answer. So for the path, we're going to compute the path for the chat to Azure OpenAI on your data. So first, we're going to set up the endpoint. Yes. And we're going to OpenAI deployment / deployment ID, which is deployment of our Azure OpenAI resource. And we're using the latest API version, which is the 2024, February 15 preview. And we need to compute the header credentials. This header credential, including the API key and including the ChatGPT URL and also ChatGPT key. I'm pretty sure that said that the last two things is not related, it's not relevant anymore. The key is the more important things here. But for the safety of it, I'll put everything here. Well, if you want to make sure it's safe, you can also, instead of put the API key, you can put the bearer tokens. that get from the Azure Active Directories, and provide the proper permissions for that for the user, and then you can get the so you can use the token instead of using directly the API key and avoid security problem. Okay, and the next thing we're going to do is compute the data source. So for using the data source, we will build the data source according to the AI search data source, which is an array of objects. And we have the type should be Azure search and some parameter, including endpoint key, index name, which is the search index. We have the vector search that we have our data already chunked and indexed there. We also set the query type of hybrid, which means vector semantic hybrid. So we have a better coverage. And we don't need this field mapping because we want to use as is, but you can use it anything you want. Row information is additional prompt. We can add into the default prompt from Azure OpenAI on your data to make sure that the result and the tone of the chat will be more relevant to our industry or to our use case. And here we also provide embedding key and embedded endpoint for Azure OpenAI on your data to actually convert the query input into embeddings before they go in and perform the search. Okay, and semantic configuration at default, of course, we need to put in scope as true to make sure that everything is in scope. Okay, and that's it. We have the data source. Now let's compute the message. In the message, we don't use any history, so we only have one object, which is the role of the user and the query content as we receive from the user. Okay, and let's get an answer. Okay, so in the answer, we compute the request body, which the method is post, header, and then we add in an additional things for the body and just message and data source, such as temperature, which is to make sure that the accuracy and the accuracy of the response will be tight, like will be grounded as much as possible, instead of go crazy or hallucinated. And we also can give some MAC token, but I prefer to go to the default. And we also use top P is top priorities one. When we have these two fields, it have much higher accuracy for the AI to return the answer, to compute the answers for us. Okay, great. And now how are we going to return the answer? So this is the format of the answer, the response from Azure OpenAI on your data. So we have a choice, an array of choice, because we don't have history. So we have only one element choice here. And each choice will have a message which have a context field, which the context field including a citation if we want to provide citation, and intent, what kind of intent from the query that the AI can conduct from that. And lately we go and finally we return the response choice number one, at index 0 with the message and the content, just the answer. But you can return also the citations and so on. How are we going to test it? Simply just send a message just send a post request with the query on the terminal and click on enter. Here I'm asking how to more external API using vTest. On the data sets here is again my blog post in my website. So I just fed it to the AI and have it indexes so I can get the response. And you can see here the response here is we have the message with the row assistant, and the content is the answer. And then in the context, we have a citations with different chunks, which is already relevant chunks here with the chunk ID, the content, the file, the title, and the URLs. We can do anything. We can decide what we're going to do with it. You can also see it in the debugging panel on of this display there. And when we continue with that, we can see it's print out on the terminal the answer that we returned from the Azure Function API. And here you can see in the answer you have a doc1, which this stands for the citation. You can use it to map it something nice, like a footnote on in the UI, and map it to the right citation according to the chunk ID in the citation or chunk citation ID. Okay, and that's it for our flows for document assistant. We have the Azure function. We have it ready. We can go on and implement our UI, use that consume these two Azure functions for our ingest and query flow. What's next? Evaluations. We have to evaluation whether our document assistant implementation is good enough, right? But what do you mean by evaluations here? Well, in this sense here, evaluations mean that we need to validate the acceptance level of quality for the document assistance service we just built. Now here come another questions. Well, this is an example of a manual evaluation for document Q&A on a data set of 40 data set with different prompts. With different prompts combinations. It can also combine with different search methods here. So in here, in the columns, you have 3 columns for 3 different prompt combinations. And for each of the test, you can see how many uncrowded, misleading, missing info, irrelevant, and conversational. And finally, what are the number of acceptable answers based on this criteria? Right. So here come the questions. What are the minimum acceptance level for us in order to decide that our doc assistant is reliable enough that we can roll out to productions and we won't get the chance to have some problem like Air Canada have with the misleading info? Who going to decide that? Well, the right answer for this question, these 2 questions, a product manager is not developer. We don't decide what is the minimum acceptance level. Product managers have to understand the industry and have to define what is the minimum acceptance level for the evaluations result. And then we need to ask ourselves how reliable the evaluations that we have done for our document assistant here. Because it all depends on a lot of factors. The data set size, here is only 40. 40 questions to come out with 50%, more than 50%, it may vary when you have 300 different questions and more different prompt combinations. And that comes to another thing, because the one who do the evaluations is human, because manual evaluations. What is the human error here? How reliable is who going to do this evaluation? Usually data scientists would do this and decide what the size of testing data to be accepted for the whole evaluation process. But when it comes to a very big data set for testing, maybe it's better to try to go for the approach of automate evaluation using LM. But again, when we use an LM, we also need to evaluation if the evaluation is correct, right? So all of this, the constraint and the things we need to decide when we talk about evaluations. And that's come to the things. Once we have the evaluations done properly and configured properly, and we have our document assistant pass the acceptance level, we can roll out it to deployment, like to production. So that's it for document assistant. We just build our document assistant service. We can extend it. We can deploy it as SDK when it can extend it API function service. So other service can use it and extend it on their application, implement inside the applications, right? So next and last thing, we're going to take a look of how we're going to build a similar document assistant using Azure AI Studio as a bonus. I hope I'm doing okay with the timing. Okay, cool. So Azure OpenAI Studio. What is Azure OpenAI Studio? So Azure OpenAI Studio is a platform that allows you to create an AI project easily when create instant resource that tie to your AI projects that allow you to connect and manage all the AI service instance in the same platform, in the same place. And you can also manage on the deployment and setting for the Azure OpenAI directly without going to Azure OpenAI Studio or Azure Portal separately. And you also can manage your indexes and your data storage where you can upload your data and you can see everything that encapsulates to a specific AI, grounded to a specific AI project instead of every single services like in the portal, Azure portal. And lastly, it's also provide the playground portal for evaluation, testing, and flow control. So let's take a look at how we create an AI project. So here we can create build your own AI copilot. We provide a project name. Okay, it's for our project. And we can go to next. And here we can provide a hub resource name for our projects to create an AI resource instance. And we can also choose the resource group. We can decide whether we want to create a new Azure OpenAI instance, or we can use the default one. And also we can create a new Azure AI search instance, or we can use the same Azure AI search existing Azure AI search instance, reuse one of them. In this case, I'm going to reuse one of them. Okay, I'm waiting for the validation. And let's move on next. Okay, so once everything is good, we click on create, then it will do the valuation again, and then it will start to create all the instance for us. Instead of us have to go and manually create each of them in our site, or have to write our own ARM template or bicep to create the instance for us. And when it's done, we will have the project with a playground ready for us to explore. So now how we going to do with the playground? For the playground, for Azure OpenAI on your data, you can ask the connections to your data set using, let's say in here, you can do it block storage or AI search. But I already have a search index, so I can just choose it, add a vector search, and choose the search style to be hybrid, acknowledge it, go to next, and save and close. And once we finish with that, when it's finished with the indexing and stuff, you can ask query and play around with the chat. So in here, I'm asking a question called how to mock the external API using vtest, and it's querying against my data set. So you can see we provide the answer with the citations for my document. Okay, and you can also copy the code in C#, Python, or Java and put it in your applications. And another thing is the form flow. You can export this into the form flow, which is the visually way of seeing what component in the flow that you can edit, and what component in the flow to make it into the query flow, for example. So you can edit here, you can view the prompt using, you can also view the code, everything in Python, unfortunately. So you need to know Python in order to read it. You can also deploy this flow. And when you deploy it, you can see the endpoint, and you can get the endpoint to consume just like the Azure function we built outside of the project. And you can also edit them using Visual Studio Code directly connect in the dev container. And here you can select to the Python code and then edit it and share between the projects, share between different users. So when you save it, it will auto reflect in the playground and in your AI project in the studio. And that's it. We just finished with the AI Studio. The downside for the AI Studio is that almost all the code in Python. So if you have a project you want to do in JavaScript or C#, you may not want to use this approach. Instead, you can go with the customized approach that we just discussed now, using our demo. So before we finish, let's take a recap about what we have been discussed so far in these sections. So first, we already understand what the main flow of the document assistant, how to build them, and how to use different LLM service for different flow component and how to implement them. And also we also understand how we can implement the document assistant using Azure OpenAI on your data. And lastly, we also discuss different aspects of evaluation of document assistant as the service before we roll out to productions. And we also take a little bit of overview how we create a document assistant using Azure AI Studio in a more like less code approach. And that's it for today. I hope you enjoy my sessions, and thank you.
Thank you so much, Maya. Thank you for your session. It was really great, and I hope you all guys enjoyed the session. We will now go to the Q&A part. So if you have any questions, please feel free to post them in the chat. I'm going to highlight a few. Let's see. We'll start with this question. Maya, so I put it also on the screen. How can I use RAG to summarize an entire document and not just by found by Azure AI search?
Well, this is a very hard question, because we've been trying to. This is also one of the requirements when we investigate about the whole document assistant here. Because summarize the entire document require you to pass the document into the AI service and get the summarization, and then we have to deal with the token limit. So for that, you can try to summarize pages and then put the pages and put the response from the Azure OpenAI, put the response from each pages together, compute it into another query, and pass it to OpenAI again. Sorry, to GPT again, and ask them to summarize from the summarization of the pages, and then you probably will get the entire document. So that's
Yeah.
That will be my approach here.
That was just an addition part of the first question, but I think you got it all covered. We have another question. I think there it is. Are there comparable libraries to Pandas, TensorFlow, NumPy, and so on? TypeScript, C#?
I don't know this answer for this question. Sorry, I have to check.
If you want to make it, if you want to ask another question, make it a bit more a different part of the question, Bargo. So please feel free to ask it, and we can share it in the chat. We also have a question if there is a repo for this session, and if we have one to share with the attendees. So Maya, if you have one, we can also add it later after the chat. We can share it with all the attendees.
Yeah, I'll share the repo to with you, and the link to the repo, and also share it on social media also, so you guys can go and pull it from there. I just need to clean up the code.
Great. I think that's it from the questions. If you don't have any other questions in the next minute, please, if you have one, please post it. Otherwise, we are actually on time. So again, this session is recorded. You can watch it on demand on our YouTube channel, the Microsoft Reactor YouTube channel. And here's also how you can get in touch with Maya if you have additional questions after this session. Yeah, so I think that's a wrap for today. Thank you all for joining, and thank you so much, Maya. It was a pleasure, and hope to see you again next week at the same time for the last session for this series. So if you haven't subscribed yet, check out our Reactor website and subscribe there to the next session. Bye, everyone. Thank you, Maya. Bye-bye.
Thank you. Bye-bye.